Imagine a world where your most critical engineering data, things like tension, compression, torque, just automatically beams back to you. No cables holding it back.
Right, we're talking telemetry, but specifically for force measurement.
Exactly, and that's what we're diving into today, Interface's wireless telemetry system, the WTS. Our goal here really is to cut through the specs. We've looked at the source material to kind of map out this system, not just what it is, but how it actually changes the game for engineering workflows. We want to pull out the most powerful features, the things that offer real advantages for, innovators and test labs.
And our sources definitely frame this as a big step forward. I mean, for any engineer who needs accurate data, getting rid of wires it removes huge logistical headaches. We're shifting from a place where the test setup limited your measurements to one where the data can follow the test pretty much anywhere.
Okay, so let's unpack that. When Interface talks about the WTS, what are we actually looking at? It's not just one gadget, right?
No, it's a whole ecosystem. You've got the load cells themselves, obviously, but then transmitters, base stations, different kinds of receivers, portable displays, even DAQ systems. And they're all designed to communicate, seamlessly.
Right.
And the key thing, which the sources really stress, is that it's modular and robust. These aren't just pieces tacked together. They're engineered to give you lab-quality data even out in the field.
Yeah.
Built to work as a system.
That modular idea immediately makes you think about scale. I mean, this isn't just for one sensor on a bench, is it?
Not at all. The capacity is pretty remarkable. You can manage data from, get this, up to 100 sensors at the same time, wirelessly.
Wow, 100 sensors. That's a lot of data points.
It's a massive network of real-time information. Yeah.
Okay, 100 sensors. But usually with wireless, you worry about range. Do they all need to be clustered together?
That's the other impressive part. The sources are talking about a range of roughly half a mile.
Half a mile? Seriously?
Half mile.
So you could go from, a small quality check station to, monitoring stress across a bridge or a huge construction site.
Exactly that. Places where running cables would be incredibly expensive, maybe dangerous, or just plain impossible.
But wait a second, half a mile, 100 sensors. What about interference? Signal drops. That sounds like a big technical challenge. How did Interface ensure reliability at that kind of scale? Was that covered?
Yeah, that's where the system design really matters. It's not just the hardware, it's the software managing it all. And that kind of hardware scale immediately pushes us into how it changes the workflow. It's one that to cut the cables.
Because you need to manage all that data effectively.
Precisely. And that's where the WTS software toolkit comes in. It's kind of the brains behind it all. It's designed for easy setup, sure, but it delivers what engineers need. Straightforward data logging, visualization. But the clever part is handling the integrity of potentially 100 simultaneous data streams in what could be a noisy environment. That's where the real value is.
And that software enables remote monitoring too, right? That seems huge.
Definitely. Being able to track and analyze results remotely. It completely changes where and how you can do critical tests. You could be overseeing a dangerous test from a safe distance, or maybe managing multiple tests across different sites from one central office, miles away.
And connecting that to the business side, the sources mentioned cost savings, but it sounds like more than just saving on the cost of copper wire.
It really is. It's about cutting out the huge, often hidden costs. Installation labor, for one.
Right.
But also the downtime when a cable gets damaged, which happens. And the safety risks of having cables snaking across an active work area.
Yeah.
Those costs add up fast.
So it makes you wonder, what can this WTS system do that a traditional wired setup just couldn't, practically speaking?
Well, the flexibility is designed right in. Things like being able to daisy chain transmitters easily to extend the range if needed, or adapting the whole setup quickly if your testing needs change. You don't have to rerun wires every single time. That's a massive time saver.
Okay, we've got the core system, the software, the range, but what about ensuring that signal actually gets there reliably, especially if you don't have a clear line of sight?
Yeah, good point. Because when you're pushing a signal half a mile, you're not just fighting distance. You've got walls, machinery, electrical noise. That's why specific components like the WTS-AR wireless repeater module are so important.
A repeater.
Exactly. It acts like a digital relay station. It picks up the signal and retransmits it, ensuring you maintain signal quality and extend the range even around obstacles.
Okay. So it's designed to overcome those real-world challenges.
Right. And you see that same thinking with the antenna options.
Oh, yeah. The sources mentioned different antennas, like the WTS-ANTB and WTS-ANTT.
Yeah. It means you can optimize the signal based on the environment. A factory floor full of metal needs a different approach than an open field test. It shows they've thought about the details of getting that signal through reliably.
That level of detail is interesting. And speaking of environment-specific stuff, there was one component that caught my eye. The WTS WSS wireless wind speed transmitter.
Ah, yes, the wind speed sensor.
It seems a bit specialized, but I guess quite powerful in certain contexts.
It is specialized, but incredibly useful. It's a rugged little unit that measures both average wind speed and, importantly, gusts. Think about industries like renewable energy, putting up wind turbines, monitoring them.
Or big construction projects.
Exactly. Cranes, temporary structures. Wind load is critical for safety and for validating structural tests. Having that environmental data wirelessly integrated right alongside your force measurements, that's hugely valuable context for your results.
Makes sense. Okay, one last piece that seems key for usability: mobility of the control point. The source has highlighted the WTS BS6 USB dongle base station.
Yeah, that little dongle is actually pretty significant. It basically turns any laptop or tablet into your base station.
That's plug and play.
Totally plug and play. So instead of needing a fixed control room, an engineer can walk around the site with a tablet, running calibrations, monitoring data, troubleshooting. It makes managing the whole network incredibly flexible.
And even that small dongle has decent range.
It does, up to 1,640 feet. So you still get really good coverage for managing all the connected modules right from your laptop.
So if I boil this all down, Interface seems to have figured out how to deliver lab-grade force measurement precision, but with the kind of mobility and scale you'd normally only dream of, like half-a-mile range, field-ready.
That's a pretty good summary, yeah.
Yeah.
That's the core promise of the WTS. It's a system sensors, transmitters, repeaters, the software all working together to give you accurate real-time data with serious flexibility, reliability, and just better efficiency overall.
And for anyone listening who wants to really dig into applying this stuff, the source material pointed towards the Force EDU section on Interface's website. Apparently it has training videos, cheat sheets, resources to help you actually deploy this WTS technology in your own projects.
Which, really brings up a final thought.
Go on.
When you consider this power remote monitoring, getting accurate data from potentially 100 sensors scattered across half a mile, how does that fundamentally change how we approach large-scale engineering tests? Does this level of wireless access make critical validation faster, safer, maybe even push testing into environments that were just too difficult or dangerous to monitor effectively before?